going to be needing them.
Yeah. Oh, I got to question 17 and go over the prep material together.
Yeah. Hold on.
I might get a little slower after 17 because I'll have to work it out then.
Where does at 17 or like just anywhere? Like what?
I've got 1 through 17, but I haven't done 17 through 26 yet.
Right.
10 more to do without.
So, could you say you want to go to the prep material, or do you want to just? I'm pretty sure they're the same. They should be the same thing.
The
Or do you
quiz
want
and
to
the
just
prep material?
yeah? Or do you want to just go through the quiz together? Because I think I think it would just be easier just to go straight to the quiz, unless you just want to talk about the prep material and then do the quiz all on our own. But no, we're required to work together. Never mind. So
Yeah.
yeah, there's
Maybe we could at least do the ones that we've all done together. I assume you all have finished
yeah,
the prep.
sure.
Yeah.
Yeah. The
Okay.
weird thing
Well,
about
maybe we
this
could just.
one, oh yeah, no, the weird thing about this one is it doesn't actually. I kind of assumed it was saying, but it doesn't actually specifically say that you have to do this first. Because remember last time it was, and they even had like a part for you to say that you've done it alone. This one doesn't say that
Right.
at all. So
Oh, the quiz doesn't?
yeah, like I guess we can go back and check the other one, but this one it's a little different. So that's why I still did it, but I didn't finish it because I was pretty busy lately. In fact, I'm still busy right now. I might run out in a few
Yeah.
minutes to check on something, but I'll
Okay.
be ready. I'm ready for the quiz. That's all I really need to say, though.
Maybe we just go through the ones that we've all done, and then we just go to the quiz. I don't think it'll take much time.
Sure. How much time? But never mind. I don't know. So,
Done before you have to go in a couple minutes.
oh no, I don't have to go anywhere. Like, I'll just like run and be right back in just a minute, sort of thing.
Okay.
Yeah. So like, I
We
have
just
all the time in the world to do the quiz. It's just I have to feed people, and all the food's upstairs. I just gotta make sure they know what to do, and that's there.
okay.
That's it. So just
Um,
when the time comes, just gotta run and take care of that.
okay. Do y'all have the answers to your questions written down
Um,
for the prep material? Because I
kind of.
started doing them just in my head.
Yeah.
Should we share our answers? Just our answers.
Okay. Yeah. I I don't have them written down. Like I said, I wasn't really doing the quiz to do it. I was just looking through it, making sure, and doing pretty much like I said, going through. I looked at the quiz, but I was mostly doing the lesson review because they're pretty much the same thing
Okay.
in the material. Oh, so yeah.
Well, I guess how about we just do the quiz together and then do as many of the questions as we can before we gotta go.
Yeah, it should be fast. And yeah, is anyone else on the time crunch?
No, I'm good for a little while.
All right. So, all right, let's just do it because it should. Like I said, it should be pretty easy. I mean, I think the longest thing that'll take is re-entering in things into the Excel, as far as I remember. All right. All right. So I guess I'll just jump right into it with number 2. Given a 90% confidence interval of 45 and 105 for a mean heart rate, which is the following, is the best interpretation of this confidence interval? And wouldn't that be? Oh, there's 9%. Oh, okay, 9% of all. If I'm not mistaken, I thought it was a 9% chance that the sample mean was between. No. Oh, what's it the true mean? Wait, I'm getting mixed up already.
I think it's B.
Yeah, B. Because I was thinking the sample mean is wait, it would be the true mean. Because the true mean's more of what we're looking for.
Yeah, I think you're right.
And we always say we are 90% confident.
Mm-hmm. Yep, I think so.
So question 3 says researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So I would say yes, because the data has been determined to be normal.
Yeah, I think so.
Through the QQ plots.
It would be C.
That's what I think.
Yeah, C.
Yeah, that's what I think too.
My bad.
Okay. So number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
I think it would be confidence interval for differences of means using independent samples.
Let's see. Let's see.
Because they're not pairs because the sample sizes are different.
Yeah.
And the random female is they're not connected to each other in any way. They're just one's just female, one's male.
Yeah. For a little bit, when I first saw it, I was thinking it like, well, there's nothing that said they were. It was a study that that were in pairs or put them against each other, but it actually did. It says males differ from females. So, and like you said, I wouldn't think it would be dependent because of they're not equal. So yeah, I would say C also.
Yeah, agree.
All right. 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a saving account balance of random sample of 30 customers. A 95% confidence interval for the mean saving account balance of the bank's customers is found to be this number and that number. Okay, which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? And I actually remember doing this one to check.
So we're trying to make it smaller, right?
We're trying to produce a smaller margin of error.
So that would be more.
I would think it would be D.
There would be more samples. or a smaller confidence?
I think the smaller confidence interval just changed the p-value. I can just enter something in real quick though.
Well, if we compute a 99% confidence interval instead of a 95, that would actually make it wider, because it's saying we're, instead of being 95% sure that we have the sample mean, we're 99% sure. But that's just because we're being a little more general.
What was I doing? Oops, I'm losing my tabs. Okay. Okay, no. Oh wait, wrong.
I think it would be D.
Yeah, that's why.
If we
I remember that.
Yeah.
increase the sample size.
Yeah, because well, okay, yeah, because I think B would have just changed the p-value only. I think. No, probably not. Anyway, no, that wouldn't have. Anyway, I'm getting confused real quick, but yeah, that's what I thought it was originally. All right.
So for question 6, it says a factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution, whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound and upper bound. Okay. I remember I did this one in the quiz, well, in the homework.
Yeah, me too.
So this is like this is one of the first equations that we learned how to do.
Yeah.
It's a z-score. Because we know the standard deviation.
All right.
So the margin of error would be 1.96. Two by the square root. So I got the margin of error of 1.96.
Yeah, that's what I got too.
Yeah. Right. Uh, 1.96. So 0.96. So the lower bound would be 998.04.
That's what I got.
Yeah, that's what I got too.
And then
Right. And
the upper
yeah.
bound would just be 1001.96. They really made it easy on us on that one, I think.
Mm-hmm. All right. All right. Whose turn is it?
I think Enetic.
It's mine.
Okay.
Give me a second. I'm kind of behind here. A second.
I've got a song stuck in my head. It's really good. It's by a Colombian singer.
Oh, I might have to do that thing real quick. No, I'll just be a minute. I'll be right
Okay.
back.
Okay.
I'm glad that these questions are actually the same as the ones on
Yeah.
the preparation assignment. Oh,
Saving a lot of time.
yeah. Have you worked on 9 yet?
What was that? ¿Qué dices?
I hecho número 9.
Yeah. Número 9. Number 20. Okay.
Yeah.
Yeah, I have it so I can read it.
En la.
So it could be number 6 in the thing. Okay, so it says to assess the accuracy of the laboratory scale, a standard way that is known to weigh 1 gram is repeatedly weighted a total of n times, and the mean of the weight is compounded. Suppose the scale readings are normally distributed with unknown mean and standard deviation equals 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin error of 0.001? I have the answer for that somewhere.
All right. All right, I'm back.
All right. We were just talking about number 9.
All right. Oh yeah, this one. Because
Yeah, I like this equation. I think it's cool.
how far did we get? Oh, yeah. By the way. So, yeah, it was just chicken and rice, but it's Asian chicken.
Soy sauce. Do you have the did you do that same question in the
Yeah, I
in the
did.
preparation assignment?
Yeah.
Oh. Hold up.
Need to quit breathing into my mic. I feel like a telemarketer with this thing on.
Oh, yeah. You know, I almost was a telemarketer because, well, when I was in Rexburg, they have lots of call centers. And I went in for the first day, and they said, come back for your orientation next Saturday. I never went back. I didn't want to go to the dungeon. Anyway.
The dungeon. Yeah, I couldn't do a call job either. It's too draining. So what did y'all get for number 9?
I got 38 for 16.
Maybe 2.
I'll be honest, I skipped it.
Do you remember the formula for this one?
I actually didn't. That's why I said I'd come back to it.
Yeah. It is from lesson lesson 10. The sample size formula. So it's n equals z-score times sigma over m. And then you square all of that. Not square, you raise it to the second power.
So that was.
Does that make?
Say that one more time. What?
It's z-score times sigma over the margin of error, or m, squared. Not squared. What do you call that?
To the power 2.
To the power of 2. Yeah.
Oops, wrong way.
I got a power nap, but I've been up since I got up really early this morning.
I might have done something wrong. I got 38.44.
4. You did
What'd
it
you
by
guys get?
hand? I got 38,416.
I must have put something in wrong.
Did you raise it to the second power?
Maybe,
I don't know, that's pretty
maybe
close.
it's this. Oops. Okay, there we go. I don't know what I did wrong the first time. I just put it in again, and I got 38.416.
Sweet.
All right. All right. Thanks.
I think it's my turn. It says the mean area mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis for mu are mu is equal to 1250 and alternative is mu is not equal to 1250. I would say it's D.
Mm-hmm.
Alternative is mu is less than 1250.
Yeah, I think so too.
Yeah.
All right.
My turn. So 11. In a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance A if
I think it's B.
P is less than A.
Mm-hmm.
yeah.
Okay.
All right. Easy. All right. 212. A group of statistics students, hey, that's us, wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from anonymous random samples of a size of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can use an ANOVA hypothesis test to answer their question.
So the variances are almost equal. Check.
Mm-hmm.
No outliers means that they are normally distributed.
Yeah,
15 from each would make 60. So I would say it is.
I think so.
Yeah, I think this number of samples doesn't really matter because they all are normal distributed.
Yeah,
So,
I think it's C.
yeah.
Yeah, I think so.
All right, Anetic.
Okay. The 13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all the patients with this particular type of cancer. The researcher has my answer was committed a type 1 error.
Yeah, me too.
Oh, what?
I said a type 1.
Yeah, A.
Oh, like for some reason I heard these things and it didn't click. I was like, yeah. Yeah.
All right.
Yeah, I think so too.
Whose turn is it? I
Maybe-
lost it. I'll do it. It says if the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2? It should go up. So I would say it's A.
Yeah.
By reducing the probability of committing a type 1, we increase the probability of committing a type 2.
Okay.
All right.
So we're reviewing
Alright.
our preparation assignments anyway.
Yeah. For some reason, I thought like these talking was coming from one of my other tabs, and I don't know why. Anyway, it keeps confusing me. All right. Well, anyway, I'll do 15. All right. The nicotine content in cigarettes of a certain brand is normally distributed. That's good. Okay. With means in milligrams, mu, and a known standard deviation of 0.17. The brand advertises that the mean nicotine content in cigarettes is 1.5, but the measurements on random samples of 100 cigarettes has the brand is given a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, the hypothesis, this thing, at a level of 0.05 level of significance, you conclude that you should
So we're supposed to use the first.
The z-score equation.
Yeah, hold up.
I think we just get the z-score and then plug it into the applet to get the probability, and then do the hypothesis test after that with the p-score.
I'm gonna do it like and the null hypothesis is 1.5. And okay. All right. If I did it right, I think I have a p score of 0. Wait. No, wait, hold up. Is greater than, yeah, 0.04. That's what I have.
Huh. I got a p-score of 0.14.
Did you do it in the applet?
Yes.
All right. How did you do it?
So I highlighted the middle,
Mhm.
and then I took my z-score, which I found to be 1.76, and put that into the z-score position, and up in the area it gives me 0.1397, which would round to 1.40.
What
No,
was your Z score?
the z-score was 0.176.
76.
What did you get?
Oh. For the highlighted middle.
No, for the z-score.
Oh, Z score. I actually put everything into the Excel sheet, which I'm not sure if I did it right. I have to double check. I like to do it twice in 2 different places and see if they add up correctly.
Mm-hmm. That's a good idea. I did it by hand. No, actually, never mind. I did it in Excel. So I had that my z-score equation looked like 1.53 minus 1.5 over 0.7 or 0.17, and that's how I got my z-score.
See if there's a way to harmonize this. All right.
Do you have it yet, Anetic?
You know, I think you might be more right.
I'm just looking at my equation. How do you have yours set up?
Mine or Anetic?
Either.
Oh, I didn't do an equation. I just plugged everything into the my Excel sheet. But only problem is the standard deviation. Is that? I don't think that's. Keep that blank. No.
The standard deviation is 1 or 0.17.
Would that? God, was there a standard deviation? Was it same for both for the sample and for the true population, or or are they separate? I think I'm pretty sure they were separate, right? Or was standard deviation only for the sample?
Sigma is for. I just know sigma is what we use for standard deviation if it's known. I think that's the equation that we're using.
Yeah. All right, I think so too. All right, so this is hard.
So we're using the formula we got, the first formula we got, right?
Yeah, z-score.
Yeah. Okay.
So the formula I have for that is x bar minus mu over sigma.
Over
Gives
sigma
us
over n squared.
yeah. No, that's if sigma is not known. That's more complicated. That's whenever we got into t-scores.
All right, let me. No, definitely not.
So the kind of exercise we're doing, it's sigma known, right? Because
Yeah,
Sigma's known.
it just gives it to us.
Okay. So let's see. And we're testing the hypothesis.
All right.
So
Both are working. I just need Anetic as a tiebreaker because I don't know if we should go with what may be incorrect information I may have done incorrectly on the Excel sheet, or do what we're both getting on the applet and the calculator.
So this is a formula I use to for the test statistics with sigma non.
Yeah, I believe it's just x bar minus mu over sigma.
And square root.
Try it one more time. I'm
Actually,
So what was your answer for that one? Did you reject it or not?
I chose to fail to reject it, but I'm just looking back at the at lesson 9 when we studied it,
Okay.
and I see the more complicated z-score formula.
I guess we can try that.
Because I think we had to find the z-score for that, and then we had to go to the applet and find the p-value, and then we had to compare those two.
Because
All right, it was very specific about giving us a sample size. Oh, wait, never mind. All right, so it gives us sigma. I'm trying to remember when we use the formula with the square root of n and when we just when we don't.
Okay.
When do we use that? All right, well, I'm just gonna use that one.
yeah, let's see.
So in that case, it would be 1.53 minus 1.5 over 0.17 over the square root of 100, which would just be 10. All right, so whenever I do it with the more complex formula, it gives me a z-score of 1.76.
Yeah.
That's
Is that what you got originally too? Because that's what I still have plugged in.
It just moved the decimal place 1.
Yeah.
So,
Oh wait, 1.76 you said.
yeah, instead of 0.176.
what do you have it for?
Before I had 0.176, and now with the more complex formula, I have 1.76 for the z-score.
Huh. Well, that doesn't make it easier because if you round that up, the area would be on the right side would be 0.04, which is what I had in mind. So pretty much it comes down to, once again, do we want to go with well, what do we want to go with? Do we want to go with the long one or the short one?
I say we go with the long one. I think the short
And
one
if not,
was from the previous unit actually, because I looked back in my notes and I don't see the short one from lesson 9 on.
all right.
And that gives us an area of 0.92 if I put that z-score into the probability applet. And in either case, we would fail to reject the null hypothesis.
Wouldn't it be on the far right side because it's greater than?
Yeah, it has to be just one side, the
Okay.
the right one.
In case it would be 0.04, like you said, and we would reject the null.
Yeah. Oh wait. Yeah, we would.
Yeah.
Okay. Because I that's what, like I said, that's what I got like originally when I plugged it all into it, but you know,
Okay.
I did it both ways, and both ways
What?
worked. But I would.
Well, which Excel tools were you using? What do you
Oh,
mean by you just plugged it in?
I was actually using probably I was just being lazy and putting them into the t-test mean, but that's probably why it wasn't exactly right. But if all the numbers
Well, it
are
should be
correct,
fairly close.
it's usually correct or pretty close to being correct all the time.
Well, and I think that's our second way of checking. So I say we reject the null.
Yeah. All right, because that was kind of hard because there was everything we were doing was working. It was just deciding which one to go with.
Yeah.
All right. Well, that was fun.
Yeah. Let's move
All
on.
right. I don't remember whose turn it was, but so I'll just go. You would like to look at the mean number of hours worked for pages per week by male students and female students. You would like a random sample of 100 for each group to test if those means are different. What is the correct statistical procedure? Would that be worked per week? I don't remember. Would that be a?
Well, they says means are different, so that would be a difference test, which would be independent samples.
Yeah, because I was just trying to remember what ANOVA was, but because if it was difference, yeah,
For the difference. All right,
So
Anetic, I think it's your turn.
D, A or D?
B.
It's the second option, right?
Yes.
Independent.
Yeah, that's what I had.
All right. I think it's your turn, Anetic.
Okay. An educator is interested in academic achievement by males and females with similar academic support systems. She decided to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
Well, so far I'm pretty sure that would be dependent, but let's find out why. Because
Because you couldn't just switch the pairs around. The relevance of the test is that they're brother and sister, that they were brought up in a similar environment.
yeah,
I think it's
and the other thing is that they were in order, like as in they were like next to each other in, I guess, sibling age. So
I would say they're dependent.
So dependent in which way? If you select for the card, you must include
Sister.
academics achievement depends to some degree on her. I
think it's D.
Yeah, I think so too.
Yeah, that makes more sense. They kind of, maybe I'm getting tired, but they kind of look the same to me somehow. Anyway, yeah, but I think D's right.
Yeah.
Right.
So 18 is a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded in dissolved. Okay. The researcher would like to conduct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? The sigma is not known. I would say confidence interval for sigma for mu when sigma is not known. He's not really compare.
I agree with that.
Hold up.
Comparing it to a second set of data.
Okay. I accidentally clicked X while moving my Excel stuff around. I didn't lose all my stuff because I saved my answers because this happened before. But can you give me 9, 10, and 15 again? What we got for those? Well, maybe not 10 because that one. Okay, yeah, 9, 10, and 15.
15, I got reject the null.
Oh, I didn't even look at that. Yeah. 10, if I remember, was D.
U is less than 1250.
Yeah. And 9 was
384.16.
oh 38.416.
No, 384.16. No decimal place.
$384.16.
Yes.
Okay.
All right. Determine the margin of error for this confidence interval. 19. That information into the one sample t-test.
Let's see.
Margin of error. I deleted it. I'll have to bring it back up.
Oh, hold up. We're on 18 still, right?
19.
Oh. All right.
What was 18? Oh yeah, the type of test.
All right. Okay. 19.
Oh, I hope this Excel thing gives us standard. Is there a difference between the standard error of the mean and the margin of error?
I actually don't think we've ever even used this standard error of the mean, because it's
They're different.
not really related.
It's different than the margin of error.
Yeah.
Okay, so
So
the margin of
to find
error
out-
would just be the mean plus or minus the.
it could be the upper bound
Mhm.
minus or plus the mean, right?
Yeah, I think so.
Yeah.
Um,
Easy way to find out. Take what you got from that and subtract it from the mean. And if you got, all right. Okay. Times, well, I got, oh yeah, I think it's correct. But my lower interval was 11.169, but I'm pretty sure the one we have in Excel is more correct.
I actually got 11.169. Oh, I guess it was 6.8. In
That's
Excel,
6.8.
Yeah, I got X68 in Excel, but on my calculator I got 6.9. Maybe I put it in wrong. 3. No. Okay, I didn't put it in wrong, but I'm gonna go with what's in Excel. Oh wait, margin of error. So hold up.
What did you
I
get?
just
What you got for the mean?
the mean, Excel says it's 13.193. And I think the margin of error is 2.025.
right, 13.195. I think so. Wait, hold up. I think. It's hard. Which way do we round? Because well, there's an easy way to figure this out. 11.194 plus 4.
Wait a second. Couldn't we just we can just find the difference between the upper level and lower level and have it and times it by 0.5. That should give us the margin of error.
Yeah. Okay. I have the space between the upper and lower confidence interval is 4.049. Divided by 2 is 2.0245. So it would be the margin of error for me. I'd say rounding up is 2.025, like you said, because
Okay.
if you took 2.025 and you subtracted it, then you would end up with you would end up with the correct lower interval, but you'd have the wrong higher interval. So pretty much I did some extra math to find one more decimal place to the right, and it's a 5. And so pretty much because it's of rounding makes things weird. So I'm going to go with 2.025.
Yeah, I think that's right.
All right. If not, well, we'll just retake it as soon as thought we were almost done, but then I was like, oh wait, it's 10 more.
Yeah. All right.
All
20
right.
lower bound.
Yeah, these you should just have already.
11.
So I'm just gonna say what I got: 11.168. Upper bound is 15.217.
15. All right. Well, I'm glad we decided to take the quiz first.
Oh, is this?
Used Hummers.
Hummers. We have mileage and. Oh, dang it. I hope we don't have to do some fancy. All right, let's just see what they're asking first. All right, I'll just read this one too. Okay. Random sample of Hummers for sale in Los Angeles and New York have been taken from listing at car.com. The data is recorded on this Excel sheet. We want to know if there is a difference in mean list pricing between Hummers on sale in Los Angeles and Hummers on sale in New York. So the two. So we need to find the two groups. Group 1 is LA, and Group 2 is the prices in LA, and the Group 2's prices in New York. Okay, because I was wondering how they'd be divided up. All right.
So first of all, is it independent or dependent? I say it's independent.
Yeah, I'd say independent.
Okay.
Because one does not affect the other.
Yeah.
So confidence interval for the difference of means using independent samples.
Yeah, that's
Because we're looking for the difference, right? Difference in prices. Yeah.
We're looking for the difference between the means, New York and Los Angeles.
So it looks like it's about the same as last time, just using a different interval. So it's calculate the 95% confidence interval for the true difference of mean. Input your answers for the upper bound. All right, so listing prices first.
Okay.
Price. Huh.
So it's C, right?
Yeah. That's what I put down. So in the Excel workbook, we'd be using paired sample tests because we're looking for the difference, right?
You read numbers. Hold on. If you read the other option, the one before it, you can tell the difference. It says the other option is confidence interval for the mean of the difference. That's when it's independent.
With yeah.
Oh,
So yeah, I think so. For 23, I'm just trying to figure out which Excel tab to use.
I think it actually might be the 2 sample t-test, because Eric did bring up an interesting point. There's not only is in the question before there's independent and dependent, but dependent is mean of differences, and confidential independent is a difference of means. So it's like, it sounds kind of weird, but that's actually are 2 separate things. Like,
yeah.
So
well, just looking at the Excel tabs, you can tell they're different. But I think that 2 sample t-test for means is also looking for the difference. So I think you're right. I think we use the tab 2 sample t-test for means.
Because I didn't think it would be that small of a difference to tell them apart. All right. Well, I've actually figured out. I love finding the margin of error for these guys, because it's actually pretty easy when it's a negative number. Oh, did I do this right? Oh yeah. So let me see. I'm just going to put in what I have for the lower bound. Oh, there is no question for the margin of error. It's just upper and lower bound. All right.
What did you get for lower bound?
Negative 423.238.
Mm-hmm. I get the same.
Okay, so what's after the point? Because I just have the whole numbers.
No, 0.238.
0.238.
Oh, that's a negative number. All right.
And for the upper bound, what's after the point?
336.
236.
No, 336.
Okay. Right. Yeah.
Okay, so we're on 25.
Yes. I'm surprised we didn't use the mileage. We usually all right, whatever. All right.
Yeah, they want to make us download more stuff.
All right.
Exercise bone data.
All right. All right.
Or bone density.
Oh, I just by looking at the the test, I think this is an ANOVA hypothesis test.
Yeah, that's what I think.
Yeah, we're talking about 3 different groups of rats.
Yep.
All right, I'm going to enter these in because I have a feeling we're going to need them. All right. All right. Okay. Let's just skip the story behind it. Just know there's a control, low jump, and a high jump. All right. So 25 would be the ANOVA. 26. What is the test statistic? Like, is that F?
Yeah. If
Yeah.
Okay.
I got 7.978.
Me too.
During our last meeting, my Excel program kept doing this weird thing whenever I tried to select. I thought I'd close it out.
Yeah. But hey,
All right.
think of it this way. I think we have, after we finish this set, we only have one more thing to download.
Sweet.
All right. So before we go to the next one, did the ANOVA test follow the same? I guess this is about 28. Does it follow the same like level significant rule?
Yeah, it does.
Okay.
All of them. And so for 27, did you guys get
Oh,
0.02?
yeah, 0.02. Oh, I'm sorry. See,
Hold on for the F statistic. Did y'all get 7.98 or 7.978?
7.9. Yes.
All right. Give the p-value 0.002.
Yes.
Is that what y'all got?
Yeah, rounding it up.
Meaning that the exercise did help the rats gain greater bone density.
Yep. Okay. I'm
And there
getting
are
tired.
Yeah. We've got 1, 2, 3, 4, 5 more left.
That's good. I just want to get this out and
Yeah.
done. Right.
There.
That's why I'm kind of skipping stuff. Right. 20. Okay, but I think 28. Wouldn't that be there is sufficient evidence to conclude that bone density of at least one of the groups is different from the mean bone density? Of at least one of the other groups?
Yeah, that's what I think.
All right. What's the difference between density of at least one of the groups is different from the mean bone density of at least one of the other groups? So it looks like that was put in there twice.
Well, one of them says it's insufficient.
Oh, okay, I see.
Okay.
Tricky. So it would be the second to last one. There is sufficient.
A, B, C, D. Oh, we're getting close.
We're almost there. All right, one more data set. See, I like this class because it actually talks about a lot of interesting stuff like bone density, direct flight costs,
It's
stuff that we.
it's creative. They have a lot of different. It's not just sciencey stuff, or how many grapes does Ryan buy on average? All right. Let's see. All right. I think we actually have to read this one because this one's has a little bit of a. Because I can't tell just by looking at it what kind of test it would be.
I think it's my turn. So it says pressures of supply and demand act directly on the prices of an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. The data are recorded. I think it would be a paired data because you're looking at the same destinations, only at two different points in time.
Yeah, I think so too because you're looking at the same data at not separate places, but pretty much we're ultimately looking for the difference, like both probably both mathematically and logically, like what is different about them, and
Yeah.
So that's I'd say paired sample t-test.
It doesn't say paired sample down below. It says dependent samples test.
Oh well.
Wait a second. Is that the same thing? I think so.
I'd assume so. And either way, they are dependent. So even if they aren't the same thing, they are. These aren't independent. These aren't one sample, obviously. This isn't an ANOVA. So both by two different types of logic that I wouldn't want to think about right now, I'd say it's A, B, C, D, E, the last one.
All right.
All right.
So that would be a two sample. Nope, it would be a paired sample test.
Oh, you wouldn't believe it though. Like the difference in prices depending on when where you buy them. It's like I can go like to Asia for like maybe $300 round trip. Maybe.
Really?
Yeah, if you go in the right time of year and like pretty much before or after summer. Anyway.
Yeah.
Oh,
geez.
yeah. I was going to go to I want to take my wife to Vietnam because that's where I served at least half my mission. And we wanted to go next year, but no, she had to go get pregnant.
That's
Yeah. So
I'm planning to go to Portland in August. to go visit my mission.
Oh yeah, everything's in Portland. Like I don't know why. Like like whenever you hear like about something cool or what's happening, it's somehow always in Portland, Oregon.
I don't know. It's a cool place. It's super weird though. I actually didn't serve my mission in Portland. I did exchanges there though. I was in the city right above it, Vancouver, Washington.
Oh.
Different than Vancouver, Canada.
I was like, Oregon. Yeah, they are close to each other though. I think, or am I forgetting?
Yeah.
I don't know.
Yeah, Vancouver's like literally right across the bridge from Portland, but nobody ever hears about it because it's basically just housing developments. That's where all the people live, and then people drive to Portland for work.
Yeah. Well, I don't know, but I'm pretty sure I'm eventually going to end up there because everything's happening in Portland. All right, 7. All right. Well, I plugged in all the numbers, and for 30, I got the test statistic. I got 1.685.
1.685. Yep. Difference.
Mm-hmm. Oh, and this is more for the p-value for next question, but it's the type of test is not equal to, and all right, and the p-value I got 0.0957. You know,
Not equal to. I got 0.095.
let me see. Oh, what's your full number? Like not rounded up.
The p-value is 0.095685151.
Oh, 0.095685151.
Yeah.
Oh,
What are you getting?
I got the same thing. I rounded before. I rounded the 6 up to the. Did I do it wrong? 0. Yeah.
I think it's just 0.096.
Yeah. I rounded in the wrong space. The 0 threw me off. All right. All right. Let's get this over with. I don't know why, but I'm not into this today.
Well, we're almost done. So it says, which of the following best expresses the conclusion of this test? Use a level of significance of 0.10. So it means that there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance. Well, no duh. I thought that was just common sense.
Yes. Sufficient. There is. Okay. Well, there is. Hold on. Level of significance A. Would that mean the confidence level is 9? 0.09? It's the P value. Or is it the other way around? Oh well. Yeah. All right. I'm gonna just pick blank answer. Is it?
So it's B.
I said there's sufficient evidence to reject the null because the p-value is smaller than alpha.
And then what's the null? Then it would be
Isn't alpha the what do you call it? Wait.
Alpha is 0.1.
I mixed things up. Yeah. Okay. Yeah, is Is that smaller than 1? I'm getting things mixed up. Yeah, I think poop. Well, one way to find out. All right. Well, I don't know why. I think I'm definitely done. So you put B, right? Sufficient evidence.
I already
Yeah.
submitted. Let me see.
Yeah, I'm gonna put that too. For some reason, I was getting confused again. Good, 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 good. Oh, I guess we missed one. I didn't even notice.
Which one did you miss? Wait a second.
Question 9. That's okay.
Did you get 32 right?
I did.
32, yep,
Yeah.
32 was right. I don't know why. I was the large small number was confusing me. Anyway, I'm
Well, I
going
think
to.
that's a wrap, folks.
All right. Yeah. All right.
All right.
Then in that case, what we got? We got a test. Meet together again on
Tomorrow.
Monday. Oh, wait. Yeah. And is that due tomorrow or due Saturday?
It's due Saturday, but it's only open tomorrow and Saturday.
Oh, okay. Yeah. So I'll
But
do
it
that as
opens
soon as I
tomorrow.
can. All right. I was not. I don't know why. I was not really into this today. All right. Well, I'll see you guys later.
Yeah.
I hope Laura does okay. Laura?
Yeah, I hope so too.
That's her.
I think she will.
Yeah. All right. Then you guys have a good weekend. I'm gonna go and sleep or something. I don't know what's going on with
See you
me.
guys next week.
Good. Bye.
Have a good weekend.